guys, a warm welcome to you. Now again we are here and we come up with the new part, that is the previous year entrance exam questions. Up till now we have formulated the complete theory. Now what we are supposed to do, we have to apply this theory on the questions, and we're going to see that what were the questions that were asked on these topics for JEE. So guys, now previous year entrance exam questions. Now let's proceed towards the first question. Okay, the first question says, which of the field pattern given below is valid for electric field as well as for the magnetic field? That means if you look at option number A, that means this shows that if we have a positive charge and the field going outside. So therefore, according to this, for the electric field this is valid, but magnetic field this is not valid. So therefore we can neglect this option. And if you look at option number B, so this is again valid for electric field, is not valid for the magnetic field, because magnetic field lines are the closed curves. So therefore option B is also incorrect. So but what do we see? If we check out option number C and option number D, that means according to this, if we look at option number D, let's look at option number D. So option number D, according to this, that means we have seen that for the electric field, for the electric field, when you have the electric dipole, the electric field goes from positive to negative. That means it goes in a curved path. And if we look at the magnetic field, the magnetic dipole, it goes from north to south. So that means what exactly is the situation? So what I'm talking about, electric field positive, negative, so it goes from something like this. So and it goes something like this, or it goes something like this. This is the situation. This is the electric direction of electric field. But when we talk about this is north, this is south, let's say, it goes from this and enters into this and again goes into this. That means it forms a closed curve. So therefore if we so from these two things we can compare and we can say that electric field are not your closed curve but magnetic field are your closed curves. So therefore if we look at option number D says that according to magnetic field this is correct. That means it is making a closed curve, but for the electric field it is not valid, because these are making closed curves. So for electric field these are not the closed curve field lines. Therefore we can neglect option number D. So therefore option number C is correct. Okay, from now on remember this thing, that this shows the induced electric and magnetic field. These field lines are for induced electric field and magnetic field lines. So that means when you're changing electric field produces magnetic field and vice versa. So this shows your induced electric field lines. So, and both these are closed lines. So that means option number C is valid for this. So it is like how we got to know that option C is correct. First, we have seen that option A was incorrect, option B was incorrect, also the option D was incorrect. So therefore, only option which is left, that is C. So, therefore, it is correct. So what exactly we can see, that if we are not getting, like if we are not able to if we don't know any concept, so it's not like that we are not able to do any question. So it is like we can go from the other side, like after neglecting the options. So this is how we can approach towards the answer. Now let's proceed towards the next question. So magnetic field lines due to the bar magnet are correctly shown. Okay, so magnetic field lines, so by the bar magnet we know that for the magnetic field lines, if this is the bar magnet north south, it starts from north and goes to south, and in between inside the bar magnet it goes from south to north, something like this, making a closed curve. So therefore incorrect, north to south. So if we look at this thing again, these are the closed curve, but inside it is going from north to south. So therefore option C should be incorrect, option D should be correct. If we check out, it is going from north to south, and from inside it is going from south to north. That is perfectly fine. So option D should be correct for this question. Now let's proceed towards the next question. Okay. A magnetic needle is kept in a non-uniform magnetic field it experiences. Okay, up till now what we have studied, that let's say this is the magnetic field lines. These are the, let's say these are the magnetic field lines, and you have studied that this is uniform magnetic field and bar magnet is being placed in the uniform magnetic field. Let's say this is north, this is south. So you have seen that on the pole strength it experiences, south part experiences force MB in this direction, that means opposite to the magnetic field lines, and north side experiences in the direction of the B, MB. And this we have studied that this is for the uniform field. That means if we talk about the system, that means on the system total force is coming out to be 0, MB in the forward direction and this MB in the reverse direction. So therefore total force, summation force is coming out to be 0. But we have seen that torque is non-zero for this thing. That means that torque is mb into, let's say this is, if this is distance d, perpendicular distance between the two forces, so torque is equals to, summation torque is non-equal to 0, and this is mb into d, either force into perpendicular distance between the two forces. So this is what we know. So therefore this is possible only in the uniform field. But what do we say? That whenever we place, or when a bar magnet is being placed in the non-uniform magnetic field, so therefore this non-uniform magnetic field means everywhere field lines or the magnitude is not constant. So therefore we can represent this by B1 value. Here let's say it is B2. So therefore summation of force will also be non-zero for this case, and hence for a non-uniform magnetic field it will experience a torque and also a force. Okay, option number A should be correct. A force and a torque both. If torque is non-zero for the uniform magnetic field, then how come it be possible that it is 0 for the non-uniform magnetic field? So therefore in this case also torque should be non-zero, and option A should be correct. Now let's proceed towards the next question. Nickel shows the ferromagnetic property at room temperature if the temperature is increased beyond Curie temperature. So you have seen that beyond, what happens to a ferromagnetic material when it is heated beyond, or when the temperature goes after Curie's temperature. So it becomes paramagnetic, and this we have already studied. So no need to go look at the other options, simply it's paramagnetism. So option A should be correct. Now let's proceed towards question number 5. Now, relative permittivity and permeability of a material are epsilon r and mu r respectively. Which of the following values of these quantities are allowed for diamagnetic material? And you know about diamagnetic material, they are asking to find out mu r. Okay, if they are asking to find out mu r, that means what we can say, what do we know? Mu r is equals to 1 plus susceptibility, and you know that the susceptibility is negative for the diamagnetic material. That means it opposes the magnetization. So therefore what we can say, that mu r will be 1 plus something, some quantity which is negative and that is less than 1. So therefore what we can say, this will be some positive quantity and that will be less than 0, sorry, less than 1, because you are taking 1 minus something. Mu r will be 1 minus some negative some quantity which is less than 1. So therefore this will comes out to be less than 1. Okay, according to this mu r should be, according to this, answer should be from C and D. Therefore we can neglect option A and B. So according to this, epsilon r is equals to 1.5 and epsilon r is equals to 0.5. Option C should be correct. Do you know why? Because epsilon r should always be greater than 1, greater than equals to 1. It cannot be less than 0. So therefore option C should be correct. So again, option D is incorrect, obviously.
So guys, if you have any query, so you can log on to our website www.askIITians.com, and here you will going to find many options, and here you have to choose. Among that options you have to choose ask a question, and upon clicking on that you will going to see a discussion board, and on the right hand side you will going to see an ask expert. Here you have to select a category. Like if you want to select a category in the physics, like general physics, so you have to select general physics. Now here you have the text box. There you can write anything to get answer from the expert, and you can also attach image by clicking on the link attach image, and after that you have to click on get answer to get answer from the expert, and we experts will going to revert back in 24 to 48 hours. Hopefully guys you have enjoyed doing the questions. You must have seen that whatever we have studied, that we were able to apply it on these questions which were asked previously. So from my side, this chapter is over. Means theoretical part, question parts, everything is over. So for more videos on Ask IITians of physics, chemistry and mathematics, stay tuned.